Last lesson, lesson 4.8, basic trig derivatives. So really we're just learning the two trig derivatives, which are the derivative of sine. So that's what that says, is derivative of sine will equal cosine. That's something you need to memorize. And then the other one is that the derivative of cosine equals negative sine of x. And yes, you're going to have to remember them, but I want to show you where they come from, that they don't just appear magically out of thin air. But the proof is a little bit complicated, so I want you to follow along and write this. It says, prove that the derivative of sine of x really is cosine of x. Well, remember how we did the derivatives by hand was the difference quotient, which says that the limit as h goes to 0 of our function, remember it's got to be x plus h plugged in, so this will be sine of x plus h, saying just a little bit more past the x value, minus sine of x over h. Okay, and then it kind of looks like, well, now what? Well, I'm hoping you remember from last year in pre-calc, we had that sheet of all those identities and formulas with trig functions. This was called the sum of angles identity. So this is sine of some angle plus some other angle. It can really be rewritten as sine of A, so sine of the first piece times cosine of the second piece plus cosine of A sine of B. So that's what we're going to do next. So I'll write limit as h goes to 0. So x is going to be like my A, h is going to be like my B. So it'd be sine of x, and I don't even put the dot, cosine of h plus cosine of x sine of h. And then I still have to write minus sine of x all over h. Okay, and then I see 1, 2, 3 terms all being divided by h. I can't simplify that at all, other than I can look at my terms and kind of regroup this how I want, because I see that this term has a sine of x, and so does this term at the end. This doesn't. This has a sine of h. So I'm going to rewrite this so that this and this are all over h, and then I'm going to put this over h as well. So I'll put limit as h goes to 0 of sine of x cosine of h. Okay, so I'm using this minus sine of x over h. And then remember that when I split a limit, that's really adding the limits together. So I'm going to write limit again as h goes to 0 of cosine of x sine of h over h. And I want you to think about, why do you think that I'm splitting it? Well, hopefully you'll remember that we learned two basic limits, and it was normally as x goes to 0, but I went ahead and changed them into h's so that you could see this. So if I had the sine of something over that something as a limit goes to 0, that was equal to 1. If I have 1 minus cosine of that something over something, the limit as h goes to 0 would be 0. I'm trying to play around with these pieces and get them to be these identities. Okay, so then my next thing would be, well, let's factor out a sine of x from each of these terms. So I've got the limit as h goes to 0, take out sine of x. So then I would be left with a cosine of h minus, since I'm taking everything from that term, that would be minus 1 over h. Maybe now you're seeing it. Plus, leave this the same, limit as h goes to 0, cosine of x times sine of h over h. Okay, the only pieces I really want are the ones with the h's, since I'm seeing when h goes to 0. So since this is kind of like a constant, I'm going to take that out in front. So I have sine of x times the limit as h goes to 0 of cosine of h minus 1 over h. Plus, same thing here. I don't really need this cosine of x. I only need the pieces that have h, so I'll bring that out in front. And that'll just get multiplied by the limit as h goes to 0 of sine of h over h. And so I've got just a little bit of an issue. I have cosine of h minus 1, but my identity says 1 minus cosine of h. When the terms are flipped, I need to multiply this by a negative 1 But either way, it doesn't matter, because if the limit is 0, multiplying that by -1, it's still 0. So really this piece right here is 0. So I'm running out of room here. I might go up to the top. So I've got sine of x times 0 plus cosine of x. And then what was this identity? Sine of h over h. That really is just 1. Well, sine of x times 0 is 0. Cosine of x times 1 is cosine of x. And 0 plus cosine of x is cosine of x. So it was a lot of work, but we just proved that the limit, or not the limit, but yes, the derivative of sine of x is cosine of x. Okay, so now let's see if we can do that a little faster on the second one. Now we're going to prove that the derivative of cosine is actually negative sine. So go ahead and write your difference quotient. The limit as h goes to 0, we'll have cosine of x plus h minus cosine of x all over h. So maybe I'll use my paper a little better this time. I'll go this way. Again, we have this sum of angles identity, but it's cosine of a plus b, and I put it right here. So if I use that identity, and these are on a colored sheet you should have still, it'll be cosine of x cosine of h minus sine of x. Oh, I'm running out of room. That should be sine. Whoop. Sine of h. Then we still need minus cosine of x all over h. Okay, and then again we need to look for how can we regroup this so that I could factor something out. Well, I see a cosine of x here and here. So let's rewrite it so that we have the limit as h goes to 0 of, I'm going to put, can I go ahead and, well, no I won't. Cosine of x, cosine of h minus cosine of x over h. And then I've got a minus in front of this term, so I'll put minus the limit as h goes to 0, sine of x, sine of h over h. Okay, I'm going to factor out cosine of x. So then I'll be left with cosine of h minus 1 over h minus, and then I've got, I'll keep this the same. Okay, and again, I only care about the pieces with h. The x terms can come out on the outside to get multiplied, like treat them like a constant. So it'll be cosine of x times the limit as h goes to 0 of cosine of h minus 1 over h minus, minus sine of x, can come out in front, times the limit as h goes to 0 of sine of h over h. And now we can use our properties over here. Remember that even if I switch up the terms, doesn't matter, this is still really a 0. So I've got cosine of x times 0, that's 0, minus sine of x, times, this is really 1, so I get negative sine of x. So that proves those two trig derivatives.